the worksheet pictures that I sent you are similar to what is going to be on the test. That's at least what he said.
For sure. Okay, so yeah, let's look at, we can do this pretty easily. So can you see my screen?
Yes.
Okay, so I'm looking at the first page compared to investments in the first. So fine, you got all this stuff, you're given some stuff. I want you to find some stuff just like physics, but you got to figure out the equation here, right?
Mm-hmm.
And so there's going to be, I don't know if you have an equation sheet, but in general, you're going to see like the amount, the future amount, some initial value. It could be different letters. I'm not sure. If you want to tell me what they are, but it's something of this effect here. Does that look familiar to you?
Mm-hmm.
Okay. And R is your rate. N is compounding period. Don't mistake that with T, that the total time, right? Like number 2 is how much does each account have after 7 years? Whereas the compounding here would be, the first one is compounded semi-annually, so that's 2, right?
Okay.
And annual would be 1. If you got monthly, that's 12. The most important part here is to notice that your rate is divided by that compounding period, okay? Because like in the simplest thing, you would have like, okay, say I have $1,000, like this is way simpler, but hopefully, so starting amount, I have 1,000, right? And so I'm given, I get 5% a year. There you go.
Okay.
Right? Does that make sense? If I get 5% a year, well, I'm going to get $50. And so if you do that, well, yeah, that's going to equal 1050, but do it another year. It's going to be 2, you're going to get your 50, but then you're going to get 5% on your initial 1,000 plus the 50.
Okay.
Is that too much, or do you understand how the compounding works?
Can you just explain it again so I'm like really sure?
Yeah, sure. So starting with 1,000, I think you get this part. So if I have $1,000 and I get 5% a year, well, guess what? I get $50. Does that make sense?
Mm-hmm. Yeah.
Why?
Because out of every $1,000, you get 5% of that, and that's 50.
Exactly, 5% per year. But when we compound, so like I said, if 1 year has gone by, well, everything we just said is true. This is your final amount, right? And pay attention to that equation because it's the same. Final, right? That's A, your principal, your initial amount. And guess what? We have 1 plus R over N, but it's just 1 plus 0.05. It's compounded once, so you just have 1. It's still times 1.
Mm-hmm.
I'm making it a little more complicated maybe, but my point is that's the same equation right there. Again, this is the simplest one because you get 5% per year. And instead, what if you did it another year, right? What if you did it another year? You get 5% a year. So yeah, this is after 1 year, but now you get 5% on that.
Mm-hmm.
Right? And so I don't know what that is, but you get 5. So, but you get 5% on your initial 1,000, $50, but you also get that extra 5% on interest on interest. That's what compound interest is. So after 2 years, it's going to be 1.5 squared, 1.05 squared times 1,000. Normally it's like, oh, I have another $50, so I have that much. Nope, wrong. You forgot to include the interest on interest, which is whatever, $2.50.
Mm-hmm.
That's the simplest case. Compounded per year, right? But your problem is not that. It's a little more complicated. That's why we went through this, because you have to understand this basic case.
Okay.
Because all this thing that we were talking about is true. Just this is your big boy formula or whatever. The general formula is what we say, right?
Mm-hmm.
So account 1 Well, how much did we start with? Invest $8,000. So P is 8,000. It always goes outside the parentheses, your principal, okay?
Okay.
If it's 4% interest, we'll just plug everything in here. Well, now it's 1 plus, well, what's the rate? 4%, 0.04. How many times is it compounded per year? On the first investment, how many times is it compounded per year?
Wait, I'm confused. Where do you find that out?
So it says that the last sentence, the last part of that first sentence, compounded semi-annually.
Oh, okay. Is that 2 times a year?
Yes, twice, every 6 months or whatever. Semi-annual is 2. So you got to divide that rate by 2 because it's compounded twice.
Okay.
But you don't forget, it's not just T up here, right?
Mm-hmm.
You got to multiply by that 2 again. So like this is the, that's why this is the first part here.
Mm-hmm.
Because the first part is graph. Well, you better have an equation or function if you want to graph something, right?
Yes.
So this is account 1, let's simplify it. So it's 8,000, 1.02 to the 2t. That's what you graph.
Okay.
And I mean, it's an exponential function, right? You can plug in a few, it's qualitative, it's going to be something like that, right?
Mm-hmm.
And then, you've got the window there, obviously. So, and then plug in important values. Like what is this value when T is equal to 0? Well, 8,000. So your y-intercept is 8,000. Yeah.
Okay.
And so how much do you have after 1 year? Well, it's 2, do the formula. It's 8,000 times 1.02, 2 times 1. Just plug in T equals 1, right?
And then is the 1 just like for the entire year?
Yes.
Okay.
And they're only gonna ask you on a yearly basis. But once you have the formula, it doesn't matter. Because if they say, how much do you have after 7.6 years? And say, well, I don't know, but plug it into the formula. T equals 7.6. I don't think they're going to ask that, but just so you know. All the work goes into finding the formula. So spend the most time on that. Because after that, it's literally, well, can you plug in the number 7 to this function, right? And yes, I'm confident you can do that. What is the next question? Plug in 30. T equals 30, right? So the hard work is finding the formula.
Okay.
Do you want me to go back so you can write that down, or you got it?
I got it.
Okay. So count 1. Let's go through it one more time. The principal goes outside the parentheses. It's 8,000 in this case. You have to do 1 plus your rate divided by how many times it's compounded. Semi-annual means twice. Then in the exponent, the parentheses is what you exponentiate is, well, how many times are you compounding? T. Okay. So I'm just going to simplify that. There you go. Again, go back. That's what the graph looks like. You got to fill in some information, but it's an exponential function. That's what a general exponential function looks like, right? You'll notice here that that's what also E to the thing looks like. So account 2, what do we got? Well, 6,000. That's the principal. Outside, not the parentheses this time, it's compounded continuously. So that means it never stops compounding, which actually doesn't exist, but it doesn't matter. So it's now E That's the factor you use. Instead of 1.02, you're now going to say e to the power of what? Well, 0.05t.
Okay.
The general formula here is the amount equals your principal, e to the rate times t, exponent, pert. This one, when you're compounding non-continuously, 1 plus the rate divided by the number of times you're compounding, nt. Okay.
Okay.
They're exponential. I don't know, it's something like that. And you plug in the numbers like you would a normal table of values, right? T, A. Well, what happens when t is 0? Plug in t equals 0. You're going to get 6,000. Makes sense. It better be, because that's what you started with, right? When t was 0. I mean, that was your principal before you invested anything. What about now when t equals 1? Well, plug in 1. So it's e to the 0.05. So e to the 0.05 is something small times your principal. And so 6307, whatever. Do that and you'll see, you'll have some points. In fact, let's take it away. You're not going to get a line, right? It's not going to be like that. Exponential functions look like this. They get much bigger and faster as your independent variable or time goes on, right? More than a parabola in long term, but less than a parabola, x squared in the short term. But they're both exponential, so the graphs are going to be the same, except you're compounding continuously here. But these are the same formulas, basically. Okay. So again, we would graph them, graphing calculator. Maybe you probably don't get one, I guess. Use your table of values and just do like three values. You know what I mean?
Okay.
And so for part 2, again, I know you can plug this in. Plug in t equals 7. That's the first one. And then t equals 30. That's part 3, right? So just plug it into your calculator. We've done it, but we can do it here. So to account 1. So, it'd be after 7 years, t equals 7. So it's 1.02 to the 14th power times 8,000. You're going to get a, decent amount of money here. I thought it'd be more than that, but it's not. Okay, that's fine. 5. I guess it's only 4%, so that makes sense. That's how much is in the account after 7 years. How much? 30 years, right? 1.02 to the 60th power, because it's 2 times 30. I'm just using that formula there to get these numbers down here.
Okay.
Usually, round to the nearest cent. So I didn't write it down, but after 7 years, well,
Yeah.
e to the, go ahead, yeah.
So to find out, like after 7 years or something like that, you're just getting table, right?
Sorry, you was cutting out a bit there. Hey, can you hear me?
Yes.
Hey, sorry, so you cut out, yeah.
Okay, my question was to find like the number of years that had passed. Do you just plug it in the equation instead of like using table or something?
What'd you say? How to solve for t, the time that's passed?
Yeah, so like the money after a certain period of time, you just plug it in, right, to the equation?
Yeah, and then solve for t.
Okay, gotcha.
So for account one, if you want to, hey, when am I going to have 10 grand? Or doubling is a common one, right? Account one, the equation is 8,000, 1.02 to the 2t. And you say, that's A, the amount. And you say, okay, I want to have 12 grand. Well, now A equals 12 grand. And then solve for t. Makes sense?
Okay.
And
Yeah.
account two, it's the same damn thing, just right, 0.05 t, solve for t. Which we'll probably go through too. But it's just taking the algebra. It's just algebra, right?
Okay.
Okay. In what year does the second account pass the first, and what amount is it? So this is solving for t, but this is somewhat complicated actually. So if you're going to do number 4 here, I mean, so you need to know what are they asking you in math, right? It's always about figuring out what these words mean in math, in an equation. What year does the second account pass the first? So you're saying they're asking you this. When is this true? Does that make the greater than, right? When is the amount in account 2 greater than the amount in account 1?
Mhm.
So what does that mean? Well, whatever it was, 6,000 e to the 0.05 t greater than whatever it was. And then
Okay.
once you can do this is kind of the hard part, getting this set up. But now it's just, okay, solve for t. And if you don't know your algebra, well, yeah, you can't do it, but it's just algebra from here on out. But the tough part is figuring out, what does this mean?
Okay. Yeah. Okay.
So, sorry, let me see. So we want to, okay, I'm going to divide both sides by 8,000 because we're trying to isolate t, right? Are you allowed to use a graphing calculator on this?
Mhm. Yes.
You are allowed to use the graphing calculator. Okay, so you graph. Okay,
Yeah.
all right, makes sense. So you graph these things. So don't do the algebra. You graph them, and when does that second graphical equation get larger than the first? Let me pull up a graphing calculator, and you can see it. Stop sharing, and then we will share this, I guess. There we go. All right, hopefully you can see this.
Yes.
So there's account 1, right? Well, what is it? It's 8,000, 1.02, maybe, to the 2t. Yeah. Because starts at 8,000. So let's get lay that out. There it is. Okay. How do I do my? Oh yeah. Okay. Wait. This is exactly what they're saying on your thing. You got to set your limits, or you're going to get a screw. See, look at my graph right now. It's correct, but that's because my T window is way too big. I hope it'll do it for me. Add T slider. Here, wait. Now I have to do this. It makes sense. What? A1? Something different. What was it? 50,000 on the thing? It's not going to give me, I don't know why it's doing that. But hopefully you see what I'm trying to do here, right? Maybe.
Mhm.
Add slider. Don't add the slider. Were you able to get this on your graphing calculator? Good
Mine
practice.
said said error when I put it in, so I don't know.
So put this in, put that, what I got highlighted in. Or Y, I think it's Y, you probably have, so Y1 on your graphing thing equals, right?
Yeah,
And then the second one, right, Y2, I guess, 6,000,
yeah.
because you shouldn't get an error on that. And obviously you're gonna have to do it tomorrow, so we should figure this out. Subscripts may only contain letters and digits. Okay.
Oh, okay, there we go.
You get it? Okay, good.
Oh, wait.
Error.
No, it didn't work. Yeah.
What kind of calculator you got? What's the
Um,
TI-84 or what?
I have the,
Give
yeah,
me the whole thing. What's the whole thing on your
that I
calculator?
have on my calculator.
Yeah, the series, you know what I'm saying? The specific series number of your
Okay.
calculator.
Oh, like, oh, okay. I have a TI-84 plus CE.
TI-84 plus, okay, plus CE. Okay, 84 plus CE. CE color graphing. Okay, wait. I might be able to do this actually. TI-84 CE software. All right, well, I'm looking at this thing. So, okay, you pressed graph. What happens when you press graph? Like clear everything out, and what happens when you press graph?
I can get the, I can
I
get
mean,
the first equation. I can get the 8,000 one graphed, but then when it goes to the second one,
gotcha.
it says error.
So you are you using the proper, you got to use the proper letter, which is E, but it's not like the letter E, because you probably have A, B, C, D, a bunch of those on there that you can access. But like E would be probably a shift. Then you want to get that exponent as well. Let's see if I can get this thing up. Give me a zoomed in. There's an E on there somewhere. You know what I'm saying? Lowercase e.
Okay, I have that one.
Okay, it's not a second shift. It's in the first column of your calculator, just below the caret, just below the power, right? E to the x, you'll see, I think. You see
Oh,
that?
okay.
That, so you want to put in 6,000, when you do your graph, you want to put in 6,000, that button, E to the x, and then put in 0.05 x.
Okay, that was the issue. There we go.
Okay. And then you got to zoom out. You got to practice if you don't know how, but you got to zoom out. And it should show you, it should give you the information like which function is which graph is which. And so to answer question 4, you got to say, you might even have to go a little crazy and say, when do these things equal each other? Because they want that specific information. They want. What were you
So
saying?
like when they cross paths.
That's when they equal each other, when they cross paths, right? They
Okay.
equal each other at that time, whatever that amount is, but they're not asking that, right? They're asking, okay, they are kind of asking that actually, but they just a little bit after that. They want it just so whatever year that is, what t value did you get? I can actually do it as well. And because you just set those equations equal to each other. Like I said, the graph and the equation is the same. So what value did you get for that?
When I put the when I found like
I
where's
got
equal,
t
my
equals 27. Yeah. T equals 27.67, right?
oh, that's not what I got. I think I'm doing the wrong thing.
You have to zoom in or solve. It sounds like you knew how to do it kind of, but you got to be real careful and make sure your functions are correct. 8,000 times 1.02 to the 2t power, right? 6,000 e to the 0.05 x t, whatever, it doesn't matter. I think it's x on yours. Those are your two graphs. And then like you said, when they cross each other, that's when they're the same amount. And then when is that one? Because I did I just solved the equation. It's 27.67.
Oh, do I have to set them equal to each other?
Yeah, but since you have the graphing calculator, your life is way easier. Remember, the
Okay.
equation and the
Wait, so
graph is the same damn thing. The graph is literally the visualization of your equation, but they are the exact same thing. So you could solve the equation, but that's a lot of work. So if you can graph it, then you graph it. Does that make sense?
okay. So I understand that part, but then what are we trying to find next? I think that's where I'm confused.
You got to find that t value. What is the value of t when they are equal?
Okay, so to find that, do you use like when I press the zoom button and then do
Yeah,
zoom?
you can zoom and trace. There is a solve function, like you can set like a solve function, but that's a little bit more complicated. You got to be good with your calculator. So if you don't want to do that, yeah, zoom for now. I mean, because I don't have it in front of me, I'd have to like mess with it and see. You could, it's on YouTube. I guarantee it's on YouTube also. How do I find when two functions equal each other on graphing the graph, whatever your thing is, put that in the Google search and you'll find a video.
Yeah.
Or zoom in, yes, and find that t value. You can trace the function and then zoom in real close. You don't even have to zoom in real close when you're tracing. You know how to trace the function, and then like your cursor will follow the curve is what I mean by trace.
Yeah. Okay, I've done that, but then where do you stop it where they intersect?
Yeah, because where they intersect is where those equations are equal to each other, which is when it's number 4, right? That's the words. You're looking at the graph now, and the equation is the same thing.
Okay.
So when
Okay.
what value of t did you get when they intersect each other?
Okay, so
Because if you didn't get 27.68 or something like that, 27.67572, then you put in the things wrong. The graph's wrong, I guess. And we're talking about the value of t, not the value of the function, but the independent variable here.
okay.
After 27 years, they will equal each other, right? That's what we're saying.
Okay, so when I trace the function, I just get the x and the y value. I think I'm
You want that x value right now. That's the year. So what is the x value, when they intersect? If you can, it's okay if you don't get it exact because they're only asking the year. So you just need an integer. You don't need to worry about the decimals.
oh, okay. So when they crossed, it's like 5.3.
Mhm. And what's the amount?
And then the y is 8,000.
So that makes sense, but you must have checked your graphs because Let me see. I'm double checking. I've triple checked already that I put in mine correctly. 8,000 times 1.02 to the 2t.
That's what I have too.
And then the other one is 6,000 e to the 0.05t. Maybe you add an extra zero in there. I don't know. Let's see. How the hell did you get 5.3? Oh, nice. I used the right equation. It's great. It's on the next page. Functions to find x. So, did you get it? Did you figure it out? Hey, sorry, I just saw that. So we're able to figure it out.
I did not. I'm still confused on what went wrong.
Yeah, so you have these in as your graphs, right? This is number one, right?
Yes.
And then this should be the second one.
Yes.
6,000 e to the 0.05 t.
Yes.
It might cross each other twice. Well, no, it would show up right here if there was two solutions. Maybe this is.
Can you like show how to use like the graphing calculator to find that? I think that's where I'm confused.
Yeah, well, I don't have, this is be like, I would be need to be like next to you. I tried to find, like here's a, I'm trying to find like free software, maybe if I can find it on your specific calculator, you know what I mean? Because I got it on Desmos here,
Mm-hmm.
it doesn't particularly help you. You must have not put in the equations right for the graph. Can you send me like a screenshot of your
Yes.
of like what the graphing table when you press graph on there, because it should give you the equations, right?
To get the equation, I have to press trace. Okay, so
don't even know. Can you send a screenshot here or?
It's loading now.
It's what?
Okay.
Loading?
It's loading. 1 second.
Oh, okay.
Let's see if I can.
Or you could show it up to the camera, or I suppose if you have an iPhone, we could FaceTime and then you can, because I need to see this real time.
Okay. I'll just show my camera then.
Okay. I have to, let's see. All right, stop sharing. Oh, there we go. Okay. Yeah,
Okay.
show me the calculator.
Can I flip it? I don't really know. Okay. I'll just show you, like, I don't think you can see it.
Yeah, that's tough. Okay, let me see. Oh, wait, can you? Oh, okay. So it says, is that 60,000? It's blurry for me, but because where's the equation? Is it at the bottom?
It's at the top, and then there's like the X and Y values on the bottom.
Where is the second graph?
The second graph, wait, what?
So you have to put in both graphs to see where they intersect.
Yeah, the second one, like the red one is the 6,000, and that's the one that curves upward. And then the second one is blue.
And
And
it
that's
should,
just like a straight line.
because they should both curve upward for sure.
Oh, okay. Is it my equations then? Can you see that?
So that's what, it's just so blurry. Well, okay, wait. Oh, there it is. 8,000. Oh God, it's like blurry. There it is. 8,000, 1.02. Maybe it's because you have to the 2t. Try putting in x for y1 and see if that helps.
2x. Okay.
And this
Oh, okay. There we go. Yeah.
cool. Okay. Remember, these are just the independent variables. And I was saying x because that's what you have to use on your calculator. And t is just like, oh, time, the independent variable. But x, remember, variables, it doesn't matter. So make sure you use the same ones. Now, did you get 27.65 or whatever? For the intersection. 6.8 or whatever.
Yeah.
Okay. So
Yeah,
see what I'm saying
why.
now? Yeah. So see what I'm saying now? After 27 years, well, 27.68 years, which is whatever, 7 months, you know what I mean? But in that 27th year, these things will equal each other.
Okay.
So then that's also when the second one surpasses the first, I think. Yeah, there's no other way. So.
Okay.
And then whatever the amount is, whatever your Y value says on your thing. Just like before, you know how to read it. It was just, we had that issue with the variables or whatever.
Yeah.
Okay, cool. So that is the part there. So again, 2 and 3 are super easy because you plug in the value, right?
Mm-hmm. Yeah.
Or if you have your graphing calculator, don't even bother with the equation. You have to find the equation to get the graph, but then go when x equals 7 on your calculator. That's how much each account will have, right?
Mm-hmm.
That's clear, right?
Yes.
Okay, cool. So if we go to the next one here, the next page that you sent me, an investment grows depending on whether investment, this is just what we were talking about before. But I'm glad I used the exact same equations. Got lucky with that. But you got to set this equation up or you don't, that's the first part, right?
Mm-hmm.
And hopefully you just got to practice and practice and practice. P is the principal, rate as a decimal, right? Don't put in 6%, don't put in 6, you got to put in 0.06. That's what 6% really is, right?
Mhm.
for this, calculate the amount in the account. Here, let me do it. Let me get it up for you. This is the second page where it has their formulas and it says, okay, remember you're using X on your graphing calculator, but X and T, you got to be comfortable with that. Okay.
Okay.
So here we are, principal. It says P, what is this? This is 12 times a year, compounded twice a year. So your equation is going to be different for each one. Why? Because it's compounded twice a year. Okay, what does it say? Compounding at regular intervals. So we use that first one, A of T equals. This is, I'm just going to write it down. This is the equation you use. Exactly what we had before, right? What's R? Well, it's 0. It's this. 4 years. So we want it every 4, T is going to be 4 years. How much cash you got after 4 years, right?
Mhm.
And then N is the number of compoundings, this thing here and there. So it's going to be, first 2 and then 6 and then 12. And then continuously, well, you use a different formula, right?
Mhm.
So here's the first part, compounding twice a year, or N equal to 2. So A of, well, T, let's do that. And it's like, okay, 8,000. We have 1 plus 0.06 divided by 2. Great, 2T, right? Equals 8,000. 1.03 to the 2T. Hooray for us. I know I went fast, but that's done.
Mhm.
And then what do you feel? How do you evaluate A of 4? How do you evaluate any function ever since the beginning of time until the universe ends? Plug 4 in for T. 2 times 4. Then this thing looks complicated, but it's just a number, right?
Mhm.
Sure.
Yeah, that makes sense.
Okay. So now how you tell me how to do what's the formula here for when it's compounded 6 times a year? Let's do it together.
Okay, so A times T.
A of T, not times.
A
Right?
of T.
It's a
Yeah,
function.
A of T equals. Wait, are we still doing account 1, right?
This is on the second page that you sent me. We did the compounding twice a year. Now we're compounding 6 times a year. And then 12 times a year after this. This is the one with the equations on the sheet.
Okay, the second page. Okay, so
You get it?
it would be A of T equals 8,000.
Yes. Parentheses.
Parentheses.
Right, because we're using the first equation.
1.03 times.
So no,
2.
1 plus 0.03 divided by how many times are you compounding? 6.
6. Okay.
Yeah.
Yeah, okay. I just wrote it down wrong.
It's all right. Then to the 6T, you got to throw that compounding in the exponent as well. Yeah.
Yes.
So then, your final formula here is going to be 1.005 to the 6T. You want to evaluate A of 4? How do you evaluate a function? Plug it in right there.
Okay.
So let's do the 12 times now. You do it. You tell me.
A of T equals 8,000 parentheses 1 plus 0.03 over 12 times, and then it's 6. And then it's to the power of 6 times 12.
No, it's got to be this number times t. That number times t is what goes in the exponent. Okay.
Oh, so it's not.
It's 12t.
Oh, 12. Okay.
That's the formula without plugging in t. Remember, we're doing a function as a function of t, so we better have a t in there somewhere.
Yeah. Okay.
They want a of 4. It's the same damn thing every time. Plug in, well, t equals 4, right?
Mm-hmm.
Okay, what about the last one? What do we do?
The compounding continuously.
Okay, what do I write down?
Okay, so
Always write down the formula first. That's what we've been doing, this a of t business, and then plug it in, because you can plug it in whatever number you want after, once you have the formula. Get the formula first.
Okay.
So what do I write down first?
So the formula for compounding continuously would be
It's right there looking at you on the sheet.
okay. T
Yes.
equals P E to RT.
Okay. What are those values? What is the actual equation for this particular? That's in general. And then what is it for this particular problem?
So for this one, it would be T equals 8,000
Yes.
lowercase e, and then the rate.
0.06. Don't ever put in 6. It's 0.06, right?
Oh yeah, okay, so that's the so it's 0.06 times t.
Yes. Only on continuous compounding do you use this formula.
Okay.
How do you evaluate a function? Plug it into the variable.
Yeah. Okay, that makes sense.
So that first one, I'll upload this video tonight, so hopefully you can watch it and go back if you need to, and send you these tonight for sure, these notes. But you're really close. You know what I mean? Like you just need a little practice. Just practice a little bit, but
Okay. Yeah.
I feel like you know what you're doing. You just need a little more practice. Okay.
Yeah. Okay.
And then the last one is if you use that blue second button. Okay, so it's second trace. That's where you find the second calc functions, right? You have to plot y equals x to the 5th plus 1/4 x to the 4th minus 4x cubed plus 1, right? That's the last picture you sent.
Mhm.
So you know how to graph that, I hope. And then the second part there is, so you press the second button, which gives you the blue things on your calculator, and then trace. That gives you calc. And I don't know what to do after that, but that's how you start it, okay? Hopefully what pops up is, what do you want to find when you say, I want the maximum, I want the local maximums.
Okay.
All right. Good luck. Let me know if you want to meet again this week, and reach out to Matthew about what's going on. I don't know if we're on next week, so, okay.
Okay, thank you.
All right. See you. Bye.
I think